Okay, tonight's chapter is over chapter 2. We're going to talk about network infrastructure and documentation. We just completed chapter 1, and we're just going to jump right into it. Here are a few of the objectives we'll be going over tonight. Identifying and describing different type of networking equipment in the commercial building area. Creating and analyzing different types of network diagrams and exploring the procedure for inventory management and labeling and very important tasks that are all used in the networking industry. So the TIA and the EIA is a joint commission for commercial buildings. These are just this is a organization that comes up with the wiring standards for networking. Um, so they come with the different wiring standards, and so when you're building a network, you have to have. Let me just open my book here. I want to. Sometimes my PowerPoints don't go into great details. I don't want to miss anything. All right, so here we go. Yeah, so this organization they come up with the networking standard for the different networks in commercial buildings and what we need to look for. So it describes the best way to install the network media to maximize the performance of the network. Apply no matter what type of media transmission or technology or networking speeds are involved. The TIA and EIA, these commissions are over that. Now, keep in mind, in the back of the book, there are glossary terms. Make sure you know all the different glossary and acronyms. In computer networking, as I stated before, they use a lot of different terminology and acronyms. So a demarc to a workstation. So this is what they're talking about here. So when you have a typical network, we're talking about the opening, the beginning stages. How do we get AT&T to Solano Community College? So the internet service provider, AT&T, they come in through one building or one location and a demarc location. This is where it first comes in. It could be a closet in the room. In the past, we would tour the Solano Community College data center, and we will see exactly where it comes in from AT&T. Once we get it here, the college takes over, and then they distribute the information to throughout the rest of the facility. So this is kind of what you will see if you were thinking about. I think Building 500 was the computer building, and the building right across from Building 500 in the front of the school is the demarc location of Solano Community College. So once it's inside the building, you can see you have a data rooms on several different floors. Um, this is where it enters the facility right here, and then from the different data closet it goes up, and then from the data closet, we have networking runs throughout the building to the different workstations and network drops. Data rooms consist of racks of several different type of equipment. This is the interest facility, incoming networks such as the internet. So we talked about that. That's right here, interest facility there. Um, the demarcation point is the device that makes it where the telecommunications service provider network ends and the organization network begins. The MDF, main distribution frame facility, that's a centralized point where the interconnections from the organization, the land, and the wind, that's where all that takes place. Then you have data rooms, you have racks, and you have patch panels. And you will see all of that in here. You got the data room, and then you got this is a vertical rack here. This is not the very best diagram. Then you got the patch drop right, the network drop for the computers to come in here as well. So that's all this slide right here is talking about. So we talked last week about a star topology or a star networking. The MDF connects to the internet service provider and on the campus and all the nearby workstations. So it still looks kind of like a star topology because it comes in here, but then the internet service provider is going to push it out, and it's going to push it to all the different workstations and computers on the network. Inside of a typical patch panel, the book described when you read the book this week, it talked about the patch panel and a couple of things that it pointed out in the patch panel. I may be jumping ahead of myself just looking at the slide here, but you can see how nice and pretty and how neat these cables are. And it talked about the different colors of the tables, and I think we're going to talk about that later on in this chapter here. But it talks about how you should label each port, you should label each cable, each drop, and it's going to make life so much easier for you because as your network patch panel gets bigger and bigger and bigger, it's going to sometimes be harder and harder to find the different types of cables in there. So in the data room, you have racks and other types of equipment. Voice over IP equipment for your telephone system is located there as well. You might have a PBX box gateway, a voice over IP endpoint and protocols. Okay, all this is the new technology. I know we watched a video last week on Bell Laboratories, and you saw the old data switching system, and seemed like a lot of you guys enjoyed that video. And one reason why I showed that is because um, in computer networking, people don't really understand that if it wasn't for the phone industry and the phone systems, we would not be where we are today. And a lot of their technology and their innovation and their vision has pushed us to the level we are now, even all the way up to the fiber optic cable. And a lot of the things that they envision, we're currently using today. The IDF, the intermediate distribution frame, provides an intermediate connection between the MDF and the endpoint of the end user equipment on the floor or in each building. And then you have different work areas that have workstations and computers and printers and other devices and wall jacks. And all that goes right back to that slide we showed earlier here. So from a demarcation workstation, here it comes in, the telephone company can. So from a phone standpoint, it comes in AT&T. You got a voice over IP gateway. This is the new system. Then we have the new switch, which sends out to all the different phones. And then you got the voice PBX box, which provides the different the kind of network monitoring and the IP addresses for the different phone systems now. Okay, so here voice equipment can be connected either voice over IP phones to an analog telephone line or to an analog phone system that's the internet. So there's pros and cons to each approach. So basically, they're saying that this is the bottom one. This is the old way of doing it, and then this is kind of like the new way of doing it up top. So this is like the legacy phone box system, and then to the phones. They kind of switch that, and then the switch here kind of goes with. So there's pros and cons. Um, Not many people that I know, other than in professional buildings, that they still use landlines. Everybody else pretty much use cell phones. I'm not sure if any of you guys in your homes right now have a landline. Sometimes it just comes free with the internet, but even still, 99% of the time, the people that I do know that have a house phone, they don't even answer it. And when they answer it, it's always a telemarketer or some type of uh, somebody trying to sell you something. So the workstations, so they benchmark off the IDF, which also branches off from the MDF. And so when you extending them out, so you have different workstations out here, and they're just branching off. So that's kind of how these how networks are working together. Anytime you running data and as a network cable, say if you start out in this industry and you're doing cabling and you're doing network cabling, uh, always run if you're gonna pull the cable, find out what the maximum amount that your budget will allow for you to pull to that location. In the early stages, when a lot of buildings, old buildings, didn't have network drops, and I used to go in and I would say, they'll say we need to put a computer system in right here. We just need one network cable. And I'm like, well, while we're pulling it, we might as well pull a backup cable just in case one break or something goes wrong. And because why have another company come out and re-pull cable again? It's always easier to pull as many as you can the first time around. And when you pull cable, you want to pull at least two, a main one and a backup. A lot of places pull four, and in these new standard network drops, they always have voice and data two separate lines. And as you can see from the shape of the connection point here, voice, which is a very smaller connector, which is I think RJ45, and data, which is RJ6, or is it, yeah, RJ6 is for data, I think. Um, so you can see the different connecting size for data jacks versus voice jacks here. So right here, this is a picture of a two different pictures of a rack system um, for servers in data and telecommunications. Okay, so you have several types. This type here is kind of like more of an open type, and this is more of a cage closed in type rack system. A couple things you can notice here when you're looking at this diagram and slide here, and this is one thing about us being in California that you're going to pull off right offhand. If you look at these two pictures here, right offhand, I can tell you which one was probably installed in California and which one was probably installed in another city or another state. Well, the one on the left here will probably be installed in California because I can tell by the bottom of the bracket here, because in California, because of earthquakes, we have to bolt everything to the floor. Okay, if it's so high up, we have to bolt it to the floor. And if you notice this one here, it's just a regular 4K and it doesn't appear to be bolted down at all. But in California, definitely we have to bolt it down. So you'll probably see more of these systems when you go around. Now you will see these cages as well. And this is like in a really nice data room. And one thing here, you see these vents here? This is the air conditioning unit. It keeps all the computers cool and free inside the data center. Now, what I don't like about this is that, like say in Sacramento, how hot it is, and you go in these data centers, it's 90, 100 degrees outside, and you go into this really nice, cool data center, and you cool off. But once you're in there for over, 15, 20 minutes, it's an ice box. And a lot of times, we'll talk about this later, but you're going to be working on these servers, and when you're standing over this vent, the air conditioner is going to wrap your pants leg, and you are freezing. So get used to it. But that's the pros and the cons of being in the data center. Okay. So let's jump to some of the types of cabling that have been used. You have patch cabling. You guys probably heard this term is interchangeable. This is a relatively short cable that connects um, one system to another. It can connect to a computer. It can connect a computer to the wall. It can, it's just a patch cable. Then you got a horizontal cable, which connects workstations to the closest data room and the switch or the housing. And then you got the backbone cable, which is the main source, which is going to the internet service provider or the MDF. So for a workstation, this right here, we have patch cables here to the data jack. And then you have, so this cable here will be considered the horizontal cable. And then you got, these can be patch cables too as well, because they're probably all in the same. But what's very, 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 so you're talking about horizontal cable from switch to the workstation. So they're basically talking about these right here. So right here, these cables here are patch cables, but they're connecting these switches together. So this switch is connected via here, this switch is connected here, and then this switch is also connected to here. So that's how you connect. So for this computer to be able to talk or send data to this computer, it'll go through the switch. That doesn't look right there. Well, it's not a correctly drawn diagram, but anyway, this switch connects to these guys here. But anyway, the point that I think they're trying to make is just that these connectors are all connected here. But one thing in networking, you want to make sure that you know the maximum distance that you have to use your cable. Because if you have a cable that's too long, it won't work, and the data won't work, and it'll fall off. Okay, so here is just another kind of depiction of the different type of horizontal cable and patch cables coming from the computer to the wall, which goes all the way up to the communication cloud, back to the patch panel, and then in the patch panel this switch is going to the MDF, which is coming out. So this is in the data room, and then this side here is pretty much is in the same room as this workstation right here. So that's kind of how they drew this diagram right here. So this picture right here kind of shows the different types of cabling that we use in networking. Unshielded twisted pair cable is exactly what you see. It's unshielded. There's no shield around it, and you have a pair of cable and they're twisted. It can't be any more simpler than that. Unshielded twisted pair of cable, and they do use a RJ45 connector. Okay. And I think I had the cables connected earlier. I think I'd say RJ6, RJ45, still a long day. So this is kind of how the cabling looked. Now, in the past, when we had class face to face, I will show you kind of how to build a cable. As a network engineer, one of the first things they'll do is if you get into the field in the entry level, you can be a cable puller, and just you pull this raw cable through the walls, and you may have to terminate it off, put a boot on it, and connect it. It's not hard to do. We may talk about that more in this week's class discussion. Cable management. Cable management is key. Cable management, because you want your cable to be nice, you want to be neat. If you take care of your cables, they will take care of you. If you have poor property cable management, then you will have a lot of communication and networking issues and networking problems. So these are just a few standards that they talk about of what you need to do when you're doing terminating the cable. Do not exceed the amount of the bend radius and things like that. You want to verify that it's working when you're done. You want to protect the cable, avoid laying cable across the floor or cords where they can be walked on, rolled on. People's desk chairs are rolling on them. You don't want to do that. And EMI, electromagnetic interference, that's when you get noise if you're putting it too close to a power source or a magnet or something like that. You want to eliminate those type of things with your cabling. A few more things is pay attention to where you lay it on the ground for grounding. You want to make sure that you don't get no hum or no interference that way. You want to leave some slack. You don't want it so tight where, if somebody touches it or it breaks or put too much stress on the cable, but you still want it nice and snug. So, and I'll let you guys kind of go through some of the rest of these more. And as you read the book, it'll probably go into them a little detail, the cable management. So, when you want to monitor the environment, it's very important that you monitor the environment in the network, because temperature and computers that I talked about slightly earlier, the humidity and the things in the room can cause the computers to act a certain way and they're not functioning properly. So you want to have a good cool ventilation system. That's why data rooms and computer closets are very cool and things like that. So you still want to monitor critical factors in your closet. You want to have different alarming systems on your switches and your routers if something goes wrong, or if something, especially on servers, but we're not really talking about that right now. But you want to make sure that here it's talking about the system. So if the temperature of the room is not correct, you want some type of alarm saying it's too hot, or it's too, or it's too much humidity, and that can have different effects and problems on computers. A lot of you guys are gamers out there, and you guys know how important it is to keep those game computers cool. Some of you guys have really fancy boxes where the gaming computers even come with like water coolers and big, huge fans and things like that. That's why computer rooms are so loud. Documentation. Documentation is key in networking, because no one wants to go into a spider web nest of wires, and you don't know what they're doing. So when you're documenting things, you can document it in several different ways. You can document them on a network diagram, and you lay out the network, and you want to document things in that way. It makes communication with coworkers more efficient when you can just point things out and you can just tell them exactly where things are. when you're troubleshooting, it definitely helps speed up the troubleshooting because if you got the proper documentation, you can pinpoint from your document, okay, this is what the problem is. It's in room A, system of 49B. And you can maybe go to that computer, put a tester in the wall, and another guy could be in, say, the data center. So, yeah, we got a bad cable, or we got something wrong with that port or that jacket, right? A mouse could have chewed on it. Who knows? You may have to get it repaired. Network diagram, geographically represent where the devices are connected. I just kind of showed that. It may show some physical layouts, how they are. You also want to get the much information as possible. Listen, the IP addresses, uh, the different types of network there are, the transmission speed. The more information, the better. Network mapping is the process of discovering and identifying the devices on the network. You want to map everything out. These are a couple of ones that are used that you can use Nmap and ZNmap. Some of you guys may have used these. You may have never heard of these, but these are just different things that we use in the community to get things network out. So here is an Nmap output from a command prompt. You can type this in the command prompt on a certain type of network, and it'll kind of list. You got um, different ports here. It kind of breaks down open, net BIOS of the system, Microsoft DNS. So it just kind of lists what the MAC address is for this particular computer and workstation and things like that. Okay. So this is another one they use from a different GUI. This is more of a Windows base, and then from a command prompt, this more have a GUI base, a little bit more neater and cleaner. More people feel comfortable with this, and then depending on what host or IP address you're on, and then this is kind of the information that it's going to give back. This is very, very important when the system drops off the network and you're trying to figure out what's going on with it. So when you Cisco come up with different systems, so when you're drawing out a network diagram, you want to use the proper symbols so to denote what you're looking at. So the router, you got the firewall, internet is in the cloud, you got your laptops. Don't just put any type of symbol on there. Try to find the right symbol for your network, and then also go on a step further. You'll put the workstation. You probably have a name for this workstation, the IP address, the port number, and you might even want to list the jack that it's plugged into. And the same here for the file server, whatever else. List the name of the computer, the IP address, what port number, wall jack, what location. You can even put like the subnet mask. The more information, the better. So just at a glance, people can look at it and know exactly what's going on. Network diagrams provide a broad snapshot of network physical and logical topologies, uh, useful for planning where to insert new switches and determine how to particular router and gateway or firewall, how they all interact. Wire schematics, the geographical representation of network wire infrastructure, and then you got rack diagrams as well. So if you get like a rack diagram, this is what you have, and this is kind of what I was talking about. You got workstation 14321 here. They're on the fast Ethernet switch, uplink here, but you really would have like an IP address for this switch here or a name for this switch here. You should have like the IP address and name for these works. You got phone 1 and 2. This is very, very broad. They didn't go into deep details, but you do know that this wireless router is 802.11 standard. That's what the standard is set for. The switches are 10 by 100 Ethernet switches. So it gave a little information here, but on your diagram, there's a lot more that you can add to make it more information. Same way here. This is a typical installation of on a rack, one of the racks in the server. You always put the UPS at the bottom. A couple of reasons, because that's the power supply and it's the heaviest. Who wants to lift the power supply way up here? And then when it goes out, you got to pull it out. It's better to drag it from the bottom here. So there are certain ways that they put things in. You put the lighter equipment on top, and patch panels are in the middle. This is where all the cables are coming in, and your servers are right around here somewhere. So that's just kind of typical how things go in there. Essential documentation, logical and physical connections on the network, the inventory, the IP addresses, the vendor. Vendor is very important. Oh, this is a GE. This is from Philips. This is from Worldmark. This is This is a Unix, or this is from Microsoft. You want to put the vendor on there because you go in there in the middle of the night, server goes down. You want to know exactly where this stuff is. You also internal operating procedures. You want to list things that will happen if things go down. What do you do to get it fixed? Policies and standards. Okay. Inventory management continues. The life cycle. How long is going to be designed for, and how long are you going to keep it on the network? The SLC should when you remove and dispose outdated assets, and in addition to and in different updates as well. So the management of the inventory, you want to know how to monitor and maintain the existing networking commitment. So you want to keep that on the network. So when you're documenting your inventory management, these are key things you want to think about and keep in mind when you're working with that as well. Labeling. I can't stress how important labeling is. I think I mentioned it slightly earlier tonight. If I didn't, you will. Every network engineer keeps a little labeler somewhere in their office. And when you see a jack that's not labeled or a cable that's not labeled, and you know what it is, don't put it off to tomorrow. Put it on there now. I do even video work, and sometimes when I may know how exactly where every cable is, and you may know exactly where every cable is on your network, but if you're sick or you're on vacation, someone else may not know that, and something goes wrong, or someone trips over a cable and pulls it out. If it's not labeled, oh shoot, where did this cable go? And you may spend hours trying to plug something in because you didn't label it. Always get a good label maker, even on label jacks and things of that nature. So right here, it kind of shows you how important labeling is. And this is typical. You have all the jacks here, and these labels here correspond with the jack in the room or wherever that system is going to be plugged into. Okay. And sometimes they even do color coordinations with the different type of cables, whereas red could be a certain type of computer or workstation, and green could be something else as well, or it could be a type of cable. You know, Cat 6, Cat 5 versus um, Cat 4 or something like that, or data or phone cables. So there's different schemes, but in your data center, your name convention, they will come up with that, and you guys will go from there. Okay. Standard business documentations may encounter RFP. So we're talking about documentations now. So in this industry, from a business perspective, for things you would do, there's a couple of terms that will just pop out from time to time. A RFP, we call it, it's a request for a proposal. You're trying to get something done. You want a vendor to come in. I have a company. I need somebody to sell me 35 computers that can program and do this and do that and have this type of software on it. So I'm gonna send out, because especially for government organizations or for hospitals, you want to be fair. You don't want to give everything always to the big guy. So you go with you're on a budget. So you send out a request for a proposal. Companies will come in and bid on that, and they will give an example. You might have, like I say, Philips might come in, GE might come in, Konica might come in, IBM might come in, and they will look at your request, and they will all give a proposal or a sales pitch on why you should go with them and what features and options they have. And then you're going to look at all those, and you're going to tell them what you're going to grade each company on, and you're going to go probably with the lowest bidder that meets your company needs best as possible. This is very, very important. Um, Say like I work in the medical industry. We built a brand new hospital in Sacramento. All those vendors want to get their equipment in a new hospital, even if it's just an ultrasound machine or a CT scanner. They want to give a proposal. Memorandum of understanding. This document is intention of two parties and intended enter into a binding agreement. So once you get the proposal, you send out a memorandum of understanding. Okay, we're going to do some business together. Let's work together, and then you go from it. So it's a document. I'm not sure if it's 100% legal, but it's like a memorandum. Then you got the statement of work. This document details what's going to be done on the project, and they list out everything that's going to be done. So these are some of the acronyms you're going to see. Case in point, you will see these on the quiz. So you guys make sure you guys kind of be familiar with some of these acronyms. And then you got SLA, Service Level Agreement. This is a legally binding contract of the two parties and what they're going to do. Okay. And then you got the Master Service Agreement, is the contract that defines the terms and features between the parties. So you have all these different ways when you're going to do business with other companies, and it protects your company and it protects the company that you're going to be doing business with. Change management in the IT industry, and then you cannot just do whatever you want without letting others know what you're about to do. Okay, and the reason, so with that, and because IT is such a key component, we came up with a change management process. So, say for instance, you're responsible for 50 servers, and these servers need to have the new Microsoft vulnerability patch. There's some virus out there, and you want to put this patch on these servers. You have to notify the business or your customers that what's going on and that you're about to change, because everything's working fine on my end. I'm not having any problems, but now you're about to go into the server and put this patch on here. What if something changes and it breaks? And you need to let me know that, okay, let me save my stuff before you take it offline. So the change management process, this is what it's all about. So it requires good planning. Network users need to know when to expect certain resources are unavailable. So the user, you gotta let the users know when you're gonna do it. Thursday night after 7:30 at night, we're gonna take down all of, Fairfield data center, which we're going to repair some much needed servers and do some patching, or we're going to do a software upgrade. Everything will be back online in 4 hours. Let everybody know. So if anybody want to work late that night, they know not to be working late. So you have common software and hardware changes. Like I said, you talk about patching, network backbone. You also need to know the change documentation that might be required. A lot of times there's some paperwork when you're doing the change. You have to send out some emails. You got to get leadership to sign off on it to make sure everything is good to go. Like I said, you just can't go in there and it's, oh, this is all bad. Case in point, real life story. I'm sitting at home. I'm working for a medical company that's responsible for, and we're responsible for everything in surgery in the cath lab where they do heart, pacemakers, and stents and things of that nature. I get a phone call saying that surgery room 1 is no longer working. So I'm on my way to the hospital. By the time I get to the hospital, I get another phone call. Surgery room 2 is no longer working. I'm like, what's going on? Then it says surgery room 3 is no longer working. Now, each time I got that page within 30 minutes, there were people in the middle of surgery on the table trying to have surgery. And when I got off the elevator running up to surgery, I noticed that in the data communication closet, it was 5 guys in there just ripping cables out the wall. And I'm like, wait a minute, what's going on? They said, oh, we decided to upgrade the network to a gigabit switch. So we're putting in the gigabit switch. I said, you can't do that during the middle of the day. They're having surgery right now. You got 3 or 4 people in the middle having surgery. You just took down all the surgery. You got to put everything back. So that's the reason why it's important to have, that's like somebody, someone doing something, they flip the light switches off on you and you need the lights. So it's very, very important to communicate, plan it out, and then if it don't work, it talks right here about rolling back. And what you're doing, it don't work, we'll put it back. Put it back the way it was, and then we'll plan it out for another day. Reverting a software upgrade. Laptop saying running low on battery. So reversing a software upgrade, you want to make sure that when you putting things back to the original state that they were before you, and everything is working the exact same way. Okay, and that's really important. So I'm sure many of you know that anytime you're doing something, it's always do a backup, right? You want to make sure you back things up before you get started, because if you don't, you definitely, if you don't, you definitely can have some problems. The same change management policy applies to all these types of changes. Processing all changes through the proper channel, minimize the negative impact on the business procedure, plan thoroughly to maximize the changes of success and change on the first attempt. Document the change throughput process. And when you're done with all that, if something does go wrong, sit down and think about it. You want to have a lessons learned. What went wrong? How could it have been better the next time? What could we have done better the next time? Um, so that's definitely something else you want to do. Still talking about change management. Generally, the larger organization, the more documentation required for making a change, which is very, very important. Required process will vary, but from the, but some of these things you may do: submit a change request with the document, understand the flow of the approval process. And that's why you really want to plan it out, because people can be on vacation and you have to get signed off on certain people and certain signatures. Because I know for a fact I've seen people get fired for just rebooting a server without doing the proper paperwork. So that's how critical in the IT industry they take this. I literally saw a person get fired on Christmas Eve because he rebooted a server without the proper paperwork. The change process is very, very critical. Okay. So that is chapter 2. That is chapter 2. I will upload this video. Make sure you guys read chapter 2. Look out for any tests. There will be a quiz this week over chapter 1, and it'll be up shortly this week. And then there will be some assignments in Cengage. Okay, you guys, everyone have a good night. Any questions, comments for anybody online tonight? I think I stopped the recording. Let me see if I stopped the recording. More. Did I stop the recording? Nope.